So here is your opening splash page that you get when you open Revit up. You're going to see that there's basically two different file types that you can open, either a project or a family. A family tends to be smaller scale objects that you might want to build lots of different or insert lots of different versions of into a project. So they tend to be tables, trusses, things of that sort, windows. You can either place these in as blocks, which are basically used over and over again the exact same way, or you can create parameters for these families that can be adapted into different, say, different pieces of furniture or different versions of a wall with the or of a window with the same typology as you're using it. And then the project is the place where everything gets collected, so lots of different families, and then of course the model of the building. So what we're going to start with today is an architectural template here in the project, in the user interface. So while that opens, I'm just going to describe briefly what you sort of see here. There's a whole series of tabs, each of which has all of the different buttons for creating different objects across the top here. The properties window here down the left side, which is where you're going to define the properties associated with each of the objects that you place into the model. Right now, level 1 is the thing that I have selected here, bolded in the project browser, and this is going to show me all of the different parameters associated with that level. And then the project browser, as I mentioned, is over here on the right. Typically, I think when you first open Revit, it's here on the left next to the properties window. It tends to be, I think it works more efficiently to sort of frame your modeling window, one with the project browser. This is where you're going to navigate to different drawings down the right side and keeping the properties window here on the left. There's a lot of visibility tools down here, including the place to change the scale and to change whether it's wireframe and the level of detail. And up here are a few kind of key buttons that you'll use that I'll touch on in a minute that are useful for adjusting and navigating the software. So I'll just run through these tabs quickly to sort of give you a sense of what's under each one, and I'll try to be brief. The architectural tab here is where you're making most of the objects you're going to need as you're modeling your building, from walls to columns and roofs, ceilings and floors. And then here, these last three buttons are all for the curtain wall system, which is quite complex and adaptive. Railings, ramps, and stairs. Here's where you can add in model lines, which are just line work that actually starts to adjust, that you can use to designate things that otherwise you haven't drawn, and text. Here's where you define openings inside of a wall or a roof plane. And down here where you can define work planes. So this is if you want to be working on a different plane inside of a level. So as you might imagine, when you're looking at a floor plan, you're working on that actual floor plan or level. If I click to level 2, then I'm working on level 2. Under structure, you're typically probably not going to use a whole lot of this during the course of the semester, but this is where you insert structural objects from foundations to beams and columns. These are going to have analytical components inside of each of them as you go to make them. So that's going to allow you to actually define load conditions on top of them and then test those load conditions either with a rudimentary system that's built into Revit or with more complex proven tools like Robot, which is a structural analysis tool that Autodesk has. Systems, again, probably not going to use a whole lot, but this is where your plumbing fixtures and ductwork is located. The Insert tab is where you can link other Revit files that you might have or import CAD files or images into your model. Annotate tab is where you're going to define more details and any sort of dimension that you're going to want to define. So whether it's spot elevations or it's actual aligned or linear dimensions on a drawing. Here's where you can draw in insulation or define regions. Detail lines are very useful, say when doing in particular wall sections, to be able to go in and add information that otherwise you wouldn't want to model, like a J-bolt inside of a foundation. Tags and annotations, where you can go in and define particular objects and associate those tags with the object that you've got. Keynote, which is basically a way to pull out a definition, say in a wall section, to define what an object is, and other symbols over here. A lot of the symbols in Revit are going to come in as you draw different things, whether they're level symbols or sections, so forth. So it's rare that you need to actually add those in. The Analyze tools are where you use the structural model that I was referencing under the Structural tab, where you can add in load conditions, define the boundaries and where those loads are actually going to transfer to the ground, and then test them. Here you can see I've actually got a component I've added in that allows me to reference the robot structural analysis, which again is a bit more comprehensive than the analysis tools that are built into Revit. Massing in sight we're going to come back to, and we're going to work on a little bit today. So a conceptual mass is basically a kind of like a Rhino model, just a massing study of a building that then can be referenced into your actual building model as a boundary plane as you look at different typologies for the building. Here are the kind of site components, so topography and trees and parking. So the topo tools we'll look at and use are relatively good compared with most other kinds of tools for that use. Collaborate, as we mentioned in the discussion on Tuesday night, is a really powerful part of this tool. Here you can define what are called work sets, which are basically zones of a given model, maybe a floor level or a particular section, that can be checked out by a particular user and worked on and then uploaded as updates to a model that might be housed on a server that a lot of different people can work with. And then you can use these other tools to sort of check for objects that might intersect with one another or to coordinate reviews of different things. These are you can see these buttons are kind of grayed out, but once we synchronize a model with a central server, this is how the buttons that you use to kind of upload and push them back. Under the View tab, this is actually quite useful. All the way down here at the end is the User Interface tab that takes us back to that opening splash page. So if you want to start a new family or something like that, you'll come back to this tab. Switch windows, which allows you to swap between windows. Each time you select a different level or elevation here in the project browser, you're gonna open a new window, and they're gonna start to pile up on top of one another. You can use the Switch Windows button here, or the other one that's kind of hidden up here, to bounce back and forth between those, or you can just double click on them in the project browser, and that'll open up the version that's already open below. Plan views is where you create new views, new elevations, new sections, or new 3D views. We'll go ahead and click on 3D view. And you'll see that here in the project browser, it creates a new tab called 3D Views. In this view, even though there's no objects in it yet, you can see that there's a little dongle here that can be used to navigate in 3D. I'll explain more of that in a minute. Also, the rendering tools are located here. So the render and render in cloud, as an educational user, you get free rendering in the cloud, which is very convenient for sort of keeping that high processor intensive stuff from going on while you're continuing to model. Just be aware at the end of the semester, educational users don't necessarily get priority, and these cloud servers do get banged on pretty hard by students from all over the world that are using them. So they tend to slow down pretty quick as everybody's producing their drawings, architecture schools everywhere. Under Manage, we find different things like material controls, object styles. This is where you can start to control some of the line weight controls, snaps, other settings. Within here, defining the actual location for this model, which would relate to the sun location and rendering tools. Add-ins is where different plugins kind of come in. So here, this is BIM 360, which is some of the stuff that actually allows you to link and collaborate on a single model. Dynamo, which we're going to use later in the semester, which is the object-oriented programming tool for Revit. Simulation CFD link, and Tally. So Simulation CFD is for doing fluid dynamics testing. So this is looking at the way that air might move around the building. And Tally is a really interesting tool developed by Kieran Timberlake that allows you to pull material quantities from your building and look at lifecycle analysis, say for for if you were trying to get a certain lead rating for your project, this tool would be really handy. And then lastly, the Modify tab at the very end here is where you actually can do your typical kind of drawing tools, right? So cutting and joining, aligning, offsetting, move, scale, rotate, 3 different trim extend tools, scaling, array, splitting objects, pinning and unpinning, which is like locking them. This align dimension tool is useful because it's actually parametric. It's something that defines a relationship between 2 objects and will maintain that linkage when you put one of those dimensions onto the object. So briefly over here, the properties dialog box. Anytime I select a given object, it's going to show you all the options that are defined by default in Revit. If I put a wall into this view, you're going to see that the options that are defined by it are the actual wall type. So if I select the modify button and then select a portion of this wall, I can actually change the preloaded wall types, or I can load other ones into this. So if I turn it into exterior EFIS, and I'm going to increase the detail here. That's actually going to define a thicker wall component based on the metal stud, EFIS on metal stud. And the base constraint is on level 1, and you can offset it off of that. So I was on level 1 when I drew the original wall. Right now it's unconnected, although I could tell it to connect to level 2, which would basically define it so that it rises up to the height of level 2. And if I were to move level 2, that wall would actually change. This one is still defined as an unconnected 20-foot high wall. You can see that there are actual dimensions associated with it that are defined by what I drew. So if you wanted to change the way in which you're actually drawing this wall, this is where you would select whether you wanted to draw it on the interior or exterior face of the wall. And it's important to note here when you're going to draw anything that many of these options come up in this little green band that goes right across the top of the interface. That's going to allow you to say change the level or change the height, whether it's unconstrained or location. Also here, the drawing tools show you that you could actually draw a square wall or say a polygonal wall. You don't have to just be drawing with single polylines along the way, and you can fillet things along as you're doing them from one object to the next. You can see there. Ooh. So I'll try that again. And you can see I've actually gone a little bit too far, so it's eating into the other walls. But in essence, you get a sense of what you can do just with those drawing tools. And then lastly, the project browser I mentioned. This is where you're going to first see all of your different floor plans, ceiling plans, different views and elevations of the project. If I go into the north view here, you're going to see the 2 levels that are predefined in any architectural template. And these levels you can adjust here. So I'm going to move this level 2 up to let's move it up to about 300 feet. I can actually select this dimension and type in 300 feet. So you can shift and adjust these however you want, and typically done in elevation. Then legends, schedules, sheets, families will all kind of talk about later on. The sheets obviously are your last set of construction documents that you might use as you get towards the end of the project. Okay, so now what we want to do is actually go into the massing in site and start talking about conceptual massing. We're going to create an in-place mass. So a mass by default is actually a family, is a new family, a conceptual mass family. You could model one of these separately in its own family drawing, or you can do it here inside of a project. That's why it's called an in-place mass. So it's a new family that you're creating, but it's already going to be by default embedded in your project so that you're visualizing it, seeing it. Say if you're on a site and you've already got a site model done, you can work with the conceptual mass there in the site. So go ahead and create an in-place mass. I'm going to go to level 1 here to start drawing it. There are two different ways that we're going to talk about creating a conceptual mass. One that is a loft between a couple of different objects, and two, which is basically taking a default object and then sculpting it, kind of pushing and pulling on points, adding points into a situation to manipulate it. I'm going to start off just by drawing a rectangle here on level 1, and then maybe filleting a couple of the corners. You can see as I do this, it's going to snap to relatively regular kinds of dimensions. And then I'm just going to draw a kind of wedge cut into this piece that I'm going to use the trim extend tools to actually Sorry, so you want to select the stuff that you want to keep. I'm going to unjoin those elements. When you're using the trim and extend tools, it's a little bit backwards from Rhino. It always takes me a second to get it fixed. I'm going to fillet one more of these. This looks a little funny. So once I've got a kind of unique boundary here, it really doesn't matter. I'm going to take select all of the curves and hit Control C to copy everything. And then I'm going to move up to level 2 and paste it. And you can see this little box allows me to align it directly over the objects that are below. And now I can actually select and say rotate it here on the second level. You can see all of this by going to the 3D view. I'm going to zoom out, and you can see that I've got these two different curves that I've defined in 3D. Once I've got the two of them defined, and I'm here in 3D selecting both of them, and I'm going to hit the Create Form button, which allows me to, which actually lofts between them and creates the kind of tower geometry that I'm going to start with for my project today. So at this point, you can hit the Finish Mass button, or you could add in other kinds of components. For now, we're going to finish the mass. We can always go back to it and manipulate it. Once you've got this defined, what we want to do is actually, or you've got one defined that you like, is we're going to put in mass floors, which is a way to start converting this conceptual mass massing study into an actual Revit set of objects. So the mass floors are going to define basically a floor plate at each of the levels in our model. Right now, we've only got levels at level 1 and level 2. So I'm going to come in here to the east elevation. Here you can see the elevation of my tower. Might be not so structural. And I'm going to use the array tool here to actually copy level 1, say on a typical like 14-foot floor-to-floor height. So I've just selected level 1 after selecting array, and I'm going to hit like 22 for the number of levels that I want. You can see that takes me up to just below the level 2, so maybe I have a taller mechanical floor here, and take that level 22 out, just selecting it and deleting it. So now I've got levels going all the way up, although you see here it doesn't actually create new floor plans. We'll talk about how to do that in a second. So now I'm going to go back to my 3D view, select the mass, and hit Mass Floors. And now I can shift select all of the floors and selecting them all with the checkbox there. And it's going to create a floor, a massing floor, at each of the different levels that I defined there in that elevation. So now I've got a series of floor plates and can start to visualize more likely what the tower might look like and getting the gradation as you go across. Now back under the Architecture tab, I can go to the Floor component, and here's where we're going to actually start making real Revit elements inside of this mass. And I'm going to hit the Architecture tab, Floor, and the little, whenever you see a little arrow below a button, you're going to know that there are other options below that. And the Floor by Face button is how you associate a floor with these mass faces that we've created, these mass floors that we've created. I can draw a box and select all of them. I'm going to change this so that it's 3-inch lightweight concrete on 2-inch metal deck, which is pretty typical for what you're going to be doing in your towers. And then select all of them here under Modify, and then hit Create Floor. And you're going to see that it's actually gone in and defined a thickened floor plate here that's the typical 3-inch lightweight metal deck, or 3 inches of concrete on 2-inch metal deck, excuse me. And we're getting these kind of echoes in the graphics because the purple mass floors are sitting on top of the floor plates themselves. Now the powerful tool here is that I can still go back to this mass and hit edit in place. And I'm going to get this little error telling it that I want to ungroup it. And what I want to do is select this this face that's on top. Sometimes when you start mousing over this, you're only going to get, say, one line of an object. The tab button in Revit allows you to kind of mouse over something and to scroll through the different things that you might be trying to select. So mouse over the edge of this curve and then hit the tab button until the top of the tower is actually selected. Once it's selected, you'll get the little XYZ axes that you can use to move that tower geometry and change it. So I've just sort of skewed it here. You can see that my floor plates have remained where they were, but the massing has actually adjusted. When I hit Finish Mass, all of the mass floors have adjusted, but those original floor plates that I made that are associated with it have all stayed where they were. So in order to adjust those, I can select any given one, and you'll see this Update to Face button comes up in the Modify tab. If I want to select all of them, and this applies to almost anything that you might be modeling in Revit, you can right-click on an object once you've selected it and go to Select All Instances, and you can either select them visible in view or in entire project. Selected in the entire project, that's going to select all those floors. Now I can hit the Update to Face button, and it's going to shift all those floor plates over into the tower, the adjusted tower geometry that I've got. So here quickly you could look at a whole series of different iterations of your project and really kind of study different ways in which the geometry could be used. The next part of this would be to think about other ways to use the Conceptual Mass tool. So it doesn't just have to be defined as a lofted object. So I'm going to go back to Massing in Sight and create another in-place mass. So again, get this prompt to label the mass. This is because, again, it's a separate family object that you're creating that's sort of outside of Revit. This time I'm just going to take a square and draw it on the ground. And then select that square. I'm going to go over, select the Modify button first to select it, and then hit Create Form from this. And you can see it just by default, it extrudes that square and allows me to start pulling it up using the XYZ button. And I can, at any point, kind of select these dimensions and tell it I want it to be 300 feet tall, or whatever height you might want. Okay, so once I've got this extruded square, there are a series of other buttons here that allow you to manipulate the object with more control. The first one I want to talk about is X-ray. When I turn X-ray on, it's going to give me little buttons that I can grab at each of the corners of the tower and allow me to actually manipulate them in different axes. So I can select the X, Y, or Z. So here, like if I want to pull up to kind of a pinnacle, I can grab the corner of the tower there. Down here at the ground plane, if I want to grab a point and so kind of create a cantilevered opening, that's going to allow me to start manipulating this guy in a more controlled kind of way. So this is more of the sort of sculpting that I was referencing earlier, where you, instead of trying to define particular curves, instead you come in here and you actually start just playing around with the control points of a given object and manipulating them until you've got what you'd like. The other thing you can do with this when you've got this defined is add in edges or profiles inside of the object. So if I kind of hit this, you can see all of the different profiles that might move through the tower. By defining this profile, it's going to give me a new set of controls at a given location. So if I wanted to make a little break here and start pulling on tweaking the kind of side of this, you can see that this is going to define it as basically as a kind of curved edge to this. If you want straight components, you need to make separate separate masses as you go up. So if you want things to kind of shift against one another, you need to do a profile and then another profile that references that to get the kind of square shift from one object to the next. You can also define new edges. So if I hit the new edge button, you see it's going to give me a new edge along that. So here again, I'll hit the add edge button. Ooh, it doesn't like that. I think it's because I've already defined this. I've already defined this other profile through the tower, and I'm kind of creating a little bit too much complexity in what I'm doing. Let's try it once more. There we go. So there I got a new one on this side. It's going to allow me to actually kind of break this edge and fold it out. So you can see you get quite a bit of control with the object. Just by adding in profiles and defining them. And then if I turn the X-ray off, it's going to show me the complete tower geometry again. All of the same things sort of apply in terms of defining, if I hit Finish Mass, defining the mass floors inside of the object per all the levels that I've got. Last piece that I want to show, I'm just going to select this mass again, hit Edit in Place. It's going to open back up this the sketch mode, which allows me to, where I'm only working on this given mass and where I have to click the checkbox or hit Cancel. With this one now, when I go to select it, I'm gonna actually try to cut away at it. So I'm gonna put a little square profile down here at the ground plane. Just drawing in 3D. Oh, excuse me, it's sitting up on top. That'll work just the same. Drawing up here on level 2. So this new square, this time when I go to the Create Form button, you can see again there's a down arrow. I'm gonna select a void form, which is actually gonna subtract from this mass. So again, you gotta do this as part of the mass that you've already created. You can't do it as a separate mass. And I'm gonna pull it down to the ground, and this is gonna cut a shaft through this tower. So you can see here when I mouse over I swing over the top of it, that it's cut all the way through, including all the way down to this little plaza space, say, that I created at the base. Now, again, just to show you how we do the mass floors, I'll shift select all of these. And it's going to go through. There are some that aren't intersecting with the tower, probably down at the ground plane, but you can see each of those kind of unique floor plates that it's created. And again, just to reference how to do the actual floor plates, you can go to the floor under Architecture, go to the floor button and hit the floor by face. And here we can select all of them and hit Create Floor. Select all those mass floors, hit Create Floor. And I've got all the floors here. Last thing I want to do, just so we can visualize what each of these are, is to add in floor plans for each of these. So I'm going to go to the View tab, and under Plan Views here, we can create new floor plans. This opens a dialog box that shows me all the levels that I've created that don't have floor plans. I'm going to select all of them and hit OK. You're going to see a whole bunch of new levels get created here. So if I say go to level 11, I can see what the given floor plate looks like at that location. Okay, that's all for today. Upload a file that's got a lofted version using 2 different curves or variations on 2 curves on 2 different levels. And then another one where you'd use the X-ray tool as well as a void form to kind of cut away at a given conceptual mass and then update them all. Create floor plates for all of them using the mass floors and then the floor button. And then add in all the levels and a 3D view of your object. Save it with your last name as the file name. So your last name .rvt as the file name. All right, see you tomorrow.